Hello. Is it loud? It's loud? Perfect. Now, everyone, come closer. Actually, if you're back, don't be shy. Awesome, 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 awesome. So it's like, like that's the great thing because I don't have much content today because I was a bit lazy. Is this being recorded? I had like this very particular type of talk because I knew there were going to be a lot of beginners in this audience. And that's why this talk is going to be about a lot of math, category theory, lambda. No, I'm just joking. There's not going to be none of that. None of that. Maybe I'm going to talk, say one thing about math, but that's all. This is painting by Francisco Goya. It's like an etching, actually, a painting, whatever. And I'm sure you can't see this. Like, there's something written there. I have like CSI skills, so enhance. It says, El sueño de la razón produce monstruos. So for all the Italians here, that's very easy. For who doesn't speak Italian, I've translated it myself, and it says, the sleep of reason produces monsters. And you can see, you're just this guy, you're there trying to get stuff to work, and you have this fucking owl, and it's like, ah. Okay? Yeah. So the sleep of reason produces monsters. And I think that's more or less my experience refactoring JavaScript. You might think, oh my god, this guy is so dramatic. But no. Checking up Hacker News or something, right? And then you look back into your editor, do some stuff, you refresh the page, but you get the very well-known error, which is undefined is not a function. This is in the private collection of Goya's etchings. You can't see it in the museum. I had to ask special. Undefined is not a function, and I like his also size uncaught type error. Who knows what that means? Whatever. And I think this is particularly scary. Look at this guy. When you're refactoring your code, right? You think, okay, my code has these architectural issues. It's hard to read. I want to change it. I want to make it nicer to use. But every time I change it, I'm screwing up the behavior. I shouldn't be changing the behavior but we are developers, right? We're very smart by definition. Some just don't do it, right? And it's I'll come back and refactor this code later. It's like telling your parents that you'll type in the morning. Yeah, especially if you work in a big team, you have tests, right? So who has tests? Yes, please. Okay. No, you have to keep them up. More. Okay. So who trusts their test suites? No, come on. You have test suites, so you must trust them. It's sometimes it's this codependent relationship. It's not very healthy. You have the tests, you trust them sort of. And then I want to ask you, how long does your test suite take to run? 1 time? How many? 10, 20? Amazing. Cool. So no one has that. I'm sorry. Who trusts their test suites to catch all regressions when you do a refactor it touches 20 files? And I just wanted to talk about fear, right? We want to make changes in our code. We have tests, but we're still scared. I'm like, come on, isn't 2019 the year of Linux on the desktop? So I'm like, we should be. Instead, we're scared. And when you're scared, you're like, well, do this, it didn't work. I'm trying to do this job for 10 years. How come I'm not good? Sometimes I feel like Homer a little bit. And I think this is quite scary. And I think this is why we always talk about imposter syndrome, right? In working 10 years, trying to vomit some HTML, this page, still doesn't work. I think about great people like Joe Armstrong. He recently passed away, but he was one of the original inventors of Erlang, the programming language. And in 2014, he was trying to set up his own blog. He was trying to use Grunt, and he couldn't get Grunt to work. And this is the guy that got like distributed systems right, but he couldn't use Grunt to run his own blog. So when I think about like my own inability to get Webpack to work, I think about this. It's like, and I think, as I said before, like we have these sort of like unhealthy relationships, but we sort of like maybe we can work, maybe it's not you, it's me. And there was like a link to this article which is called "Speed Without Wizardry," and and if you haven't seen it, it's about this Rust developer that explains why in Rust you can write very performant code without really knowing all the internals of the just-in-time compiler of V8. Right? You can either know that and be this God among humans, or use Rust and Rust will do the right thing and the machine will do it. Right? And so like. For some time, I was thinking, well, like Rust can do the thing like very nicely, but what I would really like for my code is to be safe, and without me having to be a wizard, right? I would like the computer to do the right thing, and if you think about it, that's why we have programs in the first place. Like people just like are getting tired like writing the same like calculation on a piece of paper. It's like, oh, I'm just going to invent like the Babbage system and stuff like that, and I think there is a solution out there. I think there's many solutions out there, but what I'm going to talk about today is one of them. Later, I'm going to talk about more of them. So what I'm going to talk about today is Elm. I'm just going to read now because I'm a bit tired. So it says, a delightful language for reliable web apps, generate JavaScript with great performance and no runtime exceptions. Okay, this is like like the market stuff. But I'm going to tell you a little what I like about Elm. And the first thing is a strongly typed functional programming language. I'll explain what that is later. It's designed to be, we said this. Okay, that. Strongly typed. Do you know what Solid is? Programming, there's like this way for building good software, which is called Solid, and it's an acronym, and each letter stands for something. And in the case of Solid, L is one of the few cases it's the name of the person, and the person is Barbara Liskov. So she was like this great engineer, and she wrote this paper in 1974 with Stephen Zils, and the paper is about strongly typed functional languages. And actually, strongly typed has like many different connotations, but in this case, it just means I have a function, I'm calling it with a value, and somewhere else I say this value has to have a type, and there is a emphasis type is the same. So yeah, cool. All right. So I'm going to try stuff. I need to use my mirror. Oh yeah, look at that. Perfect. And this is my slides, so you don't need to care about that. Cool, awesome. We're going to get some coding done. So let me open Node. Okay? And we're going to create a function which is add xy return x plus y. I'm going to make typos. That's fine. And we can call them like add 10, 10. But we can also do this, and foo. Or we can do add object, object, of course. Who hasn't seen object, object like in a React app? Or, like, oh, yeah, this is going to have something. No, it didn't, but that's fine. Empty list, like doesn't show. What is this going to do? Undefined? I mean, you're supposed to be the JavaScript experts. Yeah? What? But that's the thing. It's like not a number, because like you're just like like you can send anything through these pipes, and everything will do. And we get this language where no one really knows how the damn language works. And I was watching this talk yesterday called JavaScript, and it was about variable scoping and the way you have to write JavaScript like, for it to behave. And it just made me think that there's so much behavior inside JavaScript as a language, which I think is at least intuitive. You have to become this god among humans, like these like ninja, these wizard, in order to actually be able to say what's as simple as add 10 plus none do. Okay? Elm REPL. I'm going to do the same thing. So, same thing. Add xy. We're going to care about that later. Add 10, 20. Let's try add 10 foo. And you see like what the Elm compiler tells me. Foo, you can maybe you can't see it, but it has like some like red little things. It says foo is a string of type string, but add needs the second argument to be number. This some stuff, and in the end says maybe you should use string to int to convert, a string into number. And this way, all this undefined behavior is handled by. You will never have to guess what the code does. The code either does whatever it's supposed to do, or it just doesn't run. And I just wanted to focus on this. Add is a function and has number, weird arrow, number, weird arrow, number. And basically this says this function is going to take one number, it's going to take another number, and it's going to return a third number. And that's the way you read type signatures. There's like nothing magic. It's 1, 2, 3. If you look at the way we wrote it, it's like more like normal programming, right? But if you think about it, if you just like move those arrows around, you have like the arrow here and the other arrow, and this is the return value. Cool. So this is the end of the demo. Sure. So we had our add function. It does int x plus y. Okay. Actually, there's like this thing called currying, which can be either a delicious food or this way of partially applying a function. And what I mean is like you have this add function, and you just pass one number instead of two, right? And basically, in this way, you create this function, which is an add, which already has eaten this one and is waiting for the second argument. And for example, when I call add 1 and I pass 4, then it will run it. So it will do add 1 and 4, right? And I think this. Sorry. All good? And when I set 2 arguments, that can only take a single argument. You write something like this, you always have to think that you're there's like this hidden parenthesis. So every time you have a function with multiple arguments, actually what you're writing is a function that first of all takes an argument and then returns something else. In this case, it's going to be a function. And for example, in this case, it's like the same example as before. And when we create something like add 1, we have this function which is like waiting for the y, right? It has eaten this 1, and 1 is always going to, and x is always going to be 1. Script, you can take an array and double everything. And here is the same code in Elm. You can see it's just slightly moved around. This is the syntax in Elm for writing lambda function, so an anonymous function. But it's pretty similar to JavaScript, especially 2015 plus JavaScript. And I think this is like perfectly fine. But what I want to show you is the signature of this list map. It's a bit weird, right? It has variables inside the type. And basically, this means that as this function is defined, it does not specify which are the precise types that the function will operate on. So for example, in this case, when we have this map, we take a number, and the return is number multiplied by 2. So it's going to be another number, right? So in this specific case, we're going to have int that goes to int, And then this is the transformation function. And this is the input, and this is the output, right? So we could rewrite this with int, go from int to int, that transforms a list of int and obtains a list of ints. And this is exactly what I do here, right? I just call it double everything. List int goes to list int. And you can see that the code is exactly the same, like no news. And at this point, like if you've never done like type signatures, thinking, shit, I have to write the right? What's right? Sort of, and I will show you like why. Like sometimes it can be a little weird. Like in this case, I wrote a specialized map which takes an int, transforms it to a string, and then transforms a list of int to a list of string. Okay? But if you look at the implementation of the function, you can see that this is actually just list map. I haven't changed anything. The implementation has remained completely the same, but I'm just helping the compiler to know that the specialized map, even though the implementation is exactly the same as the normal list map, actually this specialized map only operates on these special types. Okay? Example, I can use the specialized map, I can use x, and then I can use this function that transforms an int to a string. It will just, do the thing. So in this case, we'll take 1, 2, 3, and transform to string 1, string 2, string 3. Okay? And the reason why I did this is because if you use this specialized map and accidentally you pass the same function that doubles everything that we had before, what do you think this is going to do? Error? Very good. Is it going to be a nice error, or is it going to be a horrible error? I really like, it shows that it just highlights the function as well. Like the compiler has like a very good way of like tracking where your code is, and it just says, look, that function you told me the specialized map should be an int to a string, but now it's an int to int. And you're like, maybe you can use these functions to convert them. Like you made a mistake there, right? And I think like this is like the main thing is that once you apply this very simple concept at scale on your SPA app, all your code is automatically checked for you. And there's this friend just like living in your computer that's like automatically checking your code, making sure that you don't make dumb mistakes. And like that's how I think about type signatures. Like you play this game as a kid, you never think about putting a square into a circle, right? So why do you do it like when you're writing JavaScript? Like, and that's what I'm saying. It's like it's not that computers can't do it. Computers clearly can do it. So I think when we should let computers do what computers are good for, is to do things in this like very precise way, right? We shouldn't be ourselves like think of us as code crafters or code is poetry or anything like that. Like I think computers should be very good at that. Then when that basic stuff is done, I can jump in and in a way and things like that. But all the stuff should be done by the computer. Do you know the reference? Who knows the reference? Yeah? No, the guy behind the background? No? It's a great movie. It's called Napoleon. But anyways, there's some basic, right? Like sometimes you get something, it can be null, it can be bad. And how does that work in Elm? I have to give you bad news, which is in Elm, really, there's no null. And the inventor of null is Tony Hoare, and he said it was his billion-dollar mistake. Sir Tony Hoare, sorry. But he said it was his billion-dollar mistake. And in Elm, you just don't have null. But this is a bit cheating, right? Because you still can, the problem doesn't go away. Just because you remove null, there is a problem. Sometimes the value is there, sometimes the value isn't. So it's just cheating a little bit. For example, let's say we want to grab the first element. There's this function, which is called listHead. You pass a list of something, and that's like the same variable as before. It's like a list of A, where A means anything, and returns this special value, which is called maybe. It's common like in a lot of functional languages. I don't want to show you how it's made, but just like how you use it first. So for example, if I call list head on an empty list, it says nothing. So basically, if you think about it, like we're trying to ask, give me your first element to an empty list. And the empty list just says, I don't have nothing, man. And instead, in the case where we have stuff, then it says just one, because one is the first element of the list. By itself, I think this is a bit pointless. You're like, oh, they have like these weird things. But this means that in Elm, you will never be. This is how you would write it yourself. If you had to write it, use the keyword type to say, I'm creating a new type, and it's called maybe A, and A is the variable. It can either be just something. So let's say we're doing it on int, so it's like a maybe int. It can be just with an int or nothing. Okay? It has to be two values. For example, if we had a function which is head to string, which grabs a list of ints and returns one string, we call list head of that list, and we use case. And case, like a case, like switch, right? And you do if it's just value, this thing will pattern match against that type, will extract the value, and you can operate on that value. So in this case, I'm calling string from int of that value to convert it to a string. If the list is empty, I'm just going to print something else. I'm just going to say, oh, sorry, the list was empty. I couldn't do nothing about that. But basically, this makes sure that every time you call, you have to handle both values. So it means that you will never be able to forget the case when the list is empty. If the list is empty, you will always have to handle it. And at first, I think like that's so much work, right? You can just do array 0 to string, and then you get this. Like the way that error hides in your code. You're very optimistic about the code. You're like, oh, it's like something easy. I just grab the first value, convert it to string. There, I'm done. And every time you write that, that's what you're not taking into consideration. And the solution to that would be to be careful. I'm really not good at being careful. I'd rather have a computer that tells me there's this case where an error could happen, do something about it. Okay, so instead of null, we have maybes, whatever. Okay, I can't read Greek, so I have to think like what this means. But it's from a book called On the Equilibrium of Planes. And this guy called Archimedes. Stand on and I will move the earth. And it's talking about levers, right? Like you put a lever and like the image shows, and no matter where you put, like there is a point where the lever has leverage and you can lift like really heavy stuff, right? Like when I have types and I have this sort of like pattern matching types, then I can make any change to the code. I don't have to guess anymore. What I mean when I say, I'm not too particular about Elm. There's like many languages out there. There's like ReasonML, PureScript, there's Rust, for example, Haskell. But all these languages have something in common, is that they have a strong types and they have a way to do pattern matching on these types. And I think you just have to try it like for real, for your own project, and just like try with it. I'll do a bunch of demos later, so you'll be able to see how it feels like to actually work with this sort of stuff. But I feel like that's like the main I'm expecting from a modern functional language, is to have like that, because once you have that, then you can change so much stuff, and then like all the errors will be in front of your eyes instead of the code. The last thing I want to talk about is custom types. In some languages, have this weird like mathematical notation, which is called algebraic data types or ADTs, whatever. Like basically, it's a way of like defining your own types. So let's say you have two kinds of users, students and teachers. I mean, I work for an education company after all. Kind, right? So I'm just writing some JavaScript. I have a function called user title. I'm passing the user kind, and I do this case statement. And then I just, return some stuff, and I use this string to case on it. And I think even you do this in Redux resolvers as well, like in the end, right? If you make a mistake and you write student, or let's say your code this case on the user kind, get a new type of user. And like there's like it's like actual code. There must be like hundreds of places where that thing is called. How do you make sure that you refactor everything? Do you have just run the suite and what's waiting for you? Otherwise, and in Elm you can make the data types, right? So like I said, you can make maybe. You can also make a type called user kind, and you pass the student and the teacher. Then every time I want to do an operation like that, I do case user kind, student, teacher. But you see, like now, the only difference is that these things are part of your code now. They're not just like dumb strings. Like they are real things. They're like like real programming stuff. And this also means that you can't make a typo here. If you miss the T, the code won't compile. If you add a new type of user, you add an admin, this code won't compile, okay? Now I'm going to show you some examples of that. Like absolutely fundamental, like being able to say to define your own types in the code and being able to do different things. Because if you think about it, like this is just a way of doing if-else. But the difference is like when you're doing if-else, it's just you alone. Instead, in this way, there's a computer, and you just can't make typos. Like, cool. So now I'm going to. Oh, now I've switched to mode. Amazing. I'm using this app, which is called Eliapp, and you can just like write like a bunch of Elm code, and you can just play with it. So in this case, I've created this little thing. And if you have used Redux, for example, this will be quite familiar, like for you. It's like very similar to the Redux pattern. You just like send message and stuff happens. Right now, as you can see, I've defined a type which is message, which only has one value, which is no op. And you can see in the update function, when I get a message and it's no op, I just return the model. It's just like a no op for real. And instead, the view function takes a model and emits some sort of thing that looks like HTML. And this is more or less like JSX, right? Okay, so hello, goodbye. And something I want to show is like, right now I have this message and just like calling it in the view. It would be nice to have this message in the model, right? So what I'm going to do to use this little thing, and you can see the type alias is just a way of defining an object. So like it will be a key and a value, right? So I'm going to say message is. Look, where you called init, you passed this thing, which is an empty thing, but it should be a model. And if I scroll down, it will show, it looks like the message field is missing. Okay? And if you go here, actually see init is here, and here I'm passing an empty record. So instead, if I pass this, and I compile again, you'll see, oh, there's another error, because I'm a bit, all over the place. So I just cut the string here. But HTML text requires a string, and now I just cut it, and I forgot. But now the compiler knows like something is wrong here. You have to pass a value there. So now I can just do model message. Okay, everything worked. And like you don't need to care about how it works. Like you just read the errors. You know nothing about the architecture. And this is like so great. Like for example, in our production code base, sometimes we have junior engineers. It's like their first experience with Elm. They don't know the code. They don't know the patterns. Still, when they get a compiler error, look at it and look. What's the mistake? And the mistake is not, oh, you have to know that this is the way the JavaScript hoists the variables, right? There's no magic knowledge. Like the code is there. Look at it. Like it's saying what it's doing. Cool. I have much time, but it's fine. Next day, Mondrian-like paintings, right? And all in Elm. And I can click, and it will generate like a bunch of them. But like you're a developer, and the product person will come and say, like this painting is really cool, but you know what would make it even cooler? Grain, right? So it's like, oh, actually, yeah, there's no grain. Like this thing. I think I broke some code. But you can see anything else. See, at some point we have a type here which says color, white, red, yellow, blue. Okay. I don't know what any. Oh, look, in this completely other bit of the code, there's a moment where someone is checking on the color and is saying that missing possibilities include grain. So, I said that, oh, here, of course. And it seems to me that someone is trying to get some representation of this. So, like, I know nothing about the code. I'm going to just like type stuff. Also, we always use Elm format, which automatically formats the code. If you not use prettier or something, because it's awesome. And you see, now I fixed the code. So now the code doesn't crash anymore, right? But if we look at the painting, there's no grain. And the reason is that like the type system can just only know so much, right? Like it's saying you're passing, this circle, the circle, and from that point of view, everything is fine, everything is kosher. But it can't really know what the code does. Like you still have to put your mind to it and like actually think about the code. It's not like magic programming. See that at some point there is a function called random color, and you see it says random weighted, and this does like frequency distribution of values. So and you can see like that, boom, we have like this change in the code. And I know that like as soon as this compiles, like I'm not guessing, I'm not hoping that the code works. The code works. I was reading some time ago this book called Working Effectively with Legacy Code. And it's about how do you deal with existing code bases like without tests and things like that. And it's saying like if you don't have tests, your only way of operating as an engineer is to edit and pray. You make some changes, then you refresh the thing, you click some buttons, and you pray that it works. And instead, when you have tests, you can just cover. That thing is always going to be checked. And I feel like, in my opinion, this is like a much faster feedback loop. It's not just this file. Like you will do it like on the whole system in a matter of like 5 seconds. Cool. Going back to the presentation again. Oh, what? Another demo? What this does. So, this is a fish. And this is something which I think is very cool. And there's this painter called Escher. He's very famous for like impossible pictures, tessellations, a bunch of stuff. I've cooked up a little bit of that using Elm. So it's creating this fish, and I've written some functions that use functional programming to draw stuff on the screen. So for example, I can do above, fish, fish, and yes, perfect. And you can see it creates 2 fishes, one above the other. Or I can say, for example, quartet, fish, fish, and this thing will create 4 fishes, okay? And like let's say I make a mistake, and I just pass 3, and the same thing will happen. Like the error it says I'm expecting something to be like this, and you're passing a picture or something. So I'm just saying that like in your normal developer experience, like this is I can't use Vim anymore, but like you have like this is the speed of the feedback loop, right? It's not, oh, let me run the test, let's hope it works. Like if I see red, I messed up somewhere. And this idea applies like to a lot of things. So for example, I can say square limit 3 of fish. I see it writes like there's no, I'm sure it works. And it's like doing something pretty complicated, but I know from the editor that it works. I don't have to go and check in the browser. And this is like square limit with a depth of 3. This is square limit with a depth of 6. The computer is doing stuff. So this is what I mean. It's like your experience is like, you know, if you make a mistake here, okay, something like this, you will always say, okay, you call something, but it's not right. So let me go back to the presentation. I did the demos, and of course, like, you know, like this sounds like really cool, but the action is in production. And this is normally when in the talks people, no, I'm using a side project. So narrating, we're using. And we have like a lot of, you know, like 100 million. Since we're the main force behind Elm, like a lot of open source libraries are written by NoRedInk or NoRed. You saw that just because it type checks, it doesn't mean it's correct. So we still need tests. We have like 100,000 lines of tests, like to make sure aside from my coworker, and I think it's great because I'm going to ask you, do you think in 4 years like production usage of a big app, how many different types of like production runtime errors can you have? More or less, if you had to estimate. Like different types. Like if you get the same error on 10 as 1, right? Just a number. Good one. If you're a very good developer. You? 20,000. Close, very close. It's actually it's 60,000. Okay, these are the production errors you get in JavaScript. And then that's like the ones like you get in Elm. For 2 years it was 0, but in the previous versions of Elm, there was a tool that as a developer voluntarily crashed when you in this state. So you can just happily crash the page. Guess what? The system can get in that state, right? So in the last version of Elm, you can't do that anymore. So debug crash, this call, can still be used in development when you're just like trying out stuff. But when you compile to the production payload, you will the compiler fail. You can't use this in production because eventually someone is going to reach that case that you thought was impossible, right? Okay, cool. So this is Richard Feldman, by the way. So I give proper attribution. And this is the last demo. So I'm going to leave some time for you, but basically, let me just clear this. I just want to show that if I find into UI src, this is like where our Elm code is. I can say -9 type l.elm, then xargs to find like this thing and compress it into a single thing, cat, and then I can do wc-l to count the lines, right? That's like the lines of thousand lines of text. And automatically generate some Elm code. So if I count that as well, you know, you get a pretty decent like amount of code. Think about the ideas that I was talking about before. You know, like that safety applies to a single file when you're playing with Ellie, but it also applies to 700,000 lines of code. Like, you know, there's a thing there inside the computer going through all those pipes and checking that never, ever, ever a triangle is going to go into a square. Okay? So that's cool and all, but I've been working on a new product which is called self-reviews that the kids can use to write, you know, something and then review their work, right? And I have a script here that just recompiles that specific endpoint. And you don't know nothing about this code. You're like Jon Snow, but just like, you know, in code speak. And you take this code, like, what is this? Bye. And you save it. First of all red. And I configure my editor to be red, so it's like a wake-up call for me. But, you know, you can see, it's like just as the case we did before, it says you were, I think this is like a view function, so I'm trying to render some template, and I'm trying, you know, just like to do a case on the kind. So we have different types of questions that we ask our students, and I just deleted one of the cases, right? And the compiler says, missing possibilities include highlight, revise. Okay, fine. It's like this is useful after all. So I save it again, boom, we're going away. And, you know, I can get a touch event, we throw a touch event. If I try to save this, I get an error. I look in the editor, it says, I cannot find a touch even constructor. This name seems closed though, touch event. Like, okay, sure, touch event. Oh, no, because I actually haven't booted the server. Like, I'm doing all this work and the server isn't even booted. It happens to me so many times that I'm doing a refactoring, I want to move this piece of code there, then, oh, let me check if I broke something. Then I load it, oh, the server isn't running. I was like, oh shit, okay, let me move the server. Maybe I'm too much. Okay, so I'm just saying that, you know, like this is like the experience that you get. Like once like this thing succeeds, I'm pretty sure that the menial errors, you know, the boring errors are fixed. I don't know about like the real code errors, you know, like maybe you're not really doing the, you know, the right view or anything like that. Some, at least like the one else, they can't tell it if it's right or not. But all this like boring stuff, it's very good at like fixing everything. And this applies like to a bunch of stuff. So it's like, you know, like we do it like use it like everywhere. You know, like imagine you have a UI component which is a button and you use it throughout your whole site. And then one day you think, oh no, this button isn't really the thing that we want. We want to add an option. How do you make sure that you grep, you search, run the tests? Instead, once you make a change there, that thing was like immediately. So if, for example, forget to add the sides on this button, crash it immediately. To button is not what you expect. You think is a type and click. Instead, we want it. So imagine having this experience like every time you're writing code. Like every time you're writing code, you're saving. The thing says, okay, it's good. So last thing, I'm going to show you like how I run tests. For example, I have like these tests for self-reviews. So the L testing will compile everything. For example, now it ran 280. But sometimes, like this loop, like a couple of seconds. Sometimes I see like on every page in the whole student can touch. And this is like the page learn thing, right? And usually this is like a thing that takes at least minutes, right? And he said, like in 2 seconds, all these files being like type checked and verified. And actually, like these are the specs being run. So it both compiles the specs and like your source files. Okay, so I'm almost done. I just wanted to show like last month we did some refactorings, and you see like 6th of March, 2000 added, 500 removed. 7th of March, similar. 7th of March, 8th of March. And every time you do these changes, imagine you refresh the browser and the thing works. Like, you don't have to hunt for, oh, I missed this, I missed that. Sometimes I do all these little to check. But a lot of times it just happens like you just make all these changes and you just work the first time. If you're curious, there's like this very nice blog post called How to Use Elm at Work. And it's on the Elm blog. So for example, like there are ways to, oh no, Slack. I don't want to do that. Sorry, Slack. There are many ways to use Elm inside an existing app. I know of a company in London where they actually use Elm with React. So React, for example, they use custom elements to make the two frameworks unique. For example, Elm can emit custom elements to the DOM, and React pick it up and that. Cool. And that's all. I made a typo here, but you can find all like the material of the presentation there. If you want to work remotely with Elm, you can check that.